Hi, welcome to another video in the series of over the wire exercises. Previously we went through Bandit and Leviathan, and today we'll be looking at Natas or Natas, which is basics of server-side website security. There are 33 levels. In case you have missed the others in the series, this is a wiki on OWASP Belfast. I've got a useful links page created which has a lot of good CTF resources if you want to get prepared for live competitions that you'll see on CTF time, or more advanced CTF challenges that you get on the likes of VulnerHub in the form of VMs. In terms of the format of these videos, I put all the challenges into a single video, and then in the description there is links just to skip to challenges. So I would recommend, rather than sitting watching through this whole video, that you go through and try these challenges yourself. If you get stuck on any particular challenge or would like to see how I've solved it in these walkthroughs, then you can always just go and look in the description, skip to whichever challenge you want to look at. So anyway, today is Natas. It's we don't have a difficulty showing here, but there are a lot of levels. I've done quite a few web security challenges in the past, so this shouldn't be too hard. In the previous videos, we've had to SSH in through our Linux terminal. In this case, it's going to be all just website addresses that we're going to go to. So let's take a copy of this. Let's just have a quick look at the notes. So each level has the password for the next level, as usual. Your job is to obtain the next level and level up. All passwords are also stored in etc natas webpass. Okay, cool. So the first level is going to be natas 0 for the username and the same for the password, and we have the URL right here. So just bear in mind that it's natas x based on whatever level we're doing. So let's go over the first level. Natas 0, Natas 0. Okay. Let's say never remember for the site, so this doesn't keep coming up. Okay, you can find the password for the next level on this page. Okay, so first thing on any web security challenge like this you want to do is have a look at the source. This one's going to be very quick. So the password for Natas is, so it's just been left in a comment on the source. Sometimes developers do leave comments in for their own benefit, which they forget to remove, which can give us some hints as to where some vulnerabilities might be, what's recently been worked on, which might still have vulnerabilities in it, etc. So that's cool. Let's go to Natas1. The username will be Natas1, and then the password, we'll just paste that in. Okay, so we're going to get this on every page. That sucks, but oh well. Okay, so you can find the password for the next level on the page, but right clicking has been blocked. Okay, well, right clicking hasn't been blocked for me. If it has, then you could simply put this view source in front of here. You could hit F12 on your keyboard. If you're using Firefox, that'll bring up a developer terminal, and you can see that there is an object here which has the Natas 1 password in it. Or, sorry, is that the... Okay, that's the password for this level. Okay, yeah, so you'll probably want to just put in the view source here. But if you're running Firefox as well, as you've seen there, the right click isn't blocked, so I wouldn't worry too much about it. So let's jump over to Natas 2. Username Natas, paste in that password, it's Natas 2. Okay. Okay, sorry, 2 seconds. Natas 2, password, okay, great. Okay, so for this challenge, it says there's nothing on this page. Something that's handy to do when you see that is highlight, just in case text has been made invisible. If not, let's have a look. Page source. Okay, so we don't have a comment with the password in it, but we do see image source files pixel. So, okay, why don't we try and just have a look at the files. So you can remove this view source, you can just go back to this address and put /files on it. Files, we have a users.txt file, and this has a list of usernames and passwords, including our Natas 3. So that's great. Let's close a couple of these windows down and jump over to Natas 3. Okay, just going to hit remember, it's a default option. Okay, there's nothing on this page once again. So again, let's view the source. No more information leaks, not even Google will find it this time. So this is a pretty common thing in capture the flag challenges, and if you're doing any kind of pen testing, it's always a good thing to look for. If you may be aware that in order to stop pages from showing up on Google, websites will add a robots.txt file to the website, which will say, okay, we don't want to display this particular site, this particular address. So in this case, they have disallowed the folder secret. So let's have a look and see what's in this folder. We have another users.txt file, and there's our password for Natas 4. Again, nice and easy. Let's go over to the new challenge, Natas 4, paste in the password. Okay. Access disallowed. You're visiting from, while authorized users should only come from Natas 5. Okay. So for a challenge like this, we're going to move over to Burp Suite. You'll have this if you're running Kali Linux, or you can just download it for your Windows system. There's no real need to run any of these challenges, I don't think, on Linux. What we want to do is jump over to this proxy tab, make sure intercept is on, and this will intercept all traffic. Just a note, if you haven't used Burp Suite before, in Firefox you'll need to go into Preferences, Advanced, Network, Connection Settings, and set up this proxy. So I don't actually have it enabled. I need it enabled, and I need this set to your home address 127.0.0.1, your local address, on port 8080, and you want to use this server for all protocols. That's great. Hit OK, and then we're going to refresh the page. So what's going to happen here? It's just going to sit as if it's loading, but it's not going to go anywhere until we hit forward or turn intercept off. So we can see here authorization basic referrer. The referrer is Natas 4, but they're only accepting stuff from Natas 5. So let's just modify the request and forward it. I'm going to turn intercept off because I don't want it to block every page we try to visit. We may not need to use Burp Suite for a lot of these challenges, so but yeah, Natas 5, that's great. We can now jump over to that site, Natas 5, paste in the password. Okay, you may have noticed there that I copied the address, but there is clearly a space at the end of it, so just be careful for that. There we go. Okay. Let me go back. Password for Natas 5. Make sure I've got this copied in properly. Remove this index.php just in case that's having an effect. try this again. Natas 5. Paste in the password. Okay. Great. Okay. So don't worry about that. That's part of this challenge. So access is disallowed as we're not logged in. View the source. Nothing really to see there. So let's go back to Burp Suite. We'll intercept the request and we'll just refresh the page. Okay. Now, there we go. You see in the cookie we have logged in equals 0. 0 is basically no in binary or false. Logged in is true or yes in binary. So let's forward that on, turn off intercept for now, and we have our password for Natas 6. Okay, so this challenge has a text box. It's asking us to input a secret and submit it to the server. We have a view source code option, so we can go in here and have a look at the source, and we can see that there's a PHP script which is checking if the value submitted in the post request, if it exists, and so if we've posted something, and if what we've posted equals a secret variable they have, then give us a password. If not, then just print wrong secret. So what you will note is that it includes this file. So let's take a copy of this and let's put in the site. It doesn't appear to be anything interesting here, but as we've seen for the last few challenges, we should view the page source, and we have a secret. So let's go back to the page. Let's input the secret and submit it. And there we go, we have our password for Natas 7. Okay. So this page has 2 links on it. But without even going to either of those links, we can see that the source code has a hint. The password for web user Natas 8 is in etc Natas webpass Natas 8. Okay. First thing we'll do, as usual, is try and copy that over. No luck. It looks like this might be a directory traversal challenge. So if we try ... // that's going to go back a few directories and hopefully go into etc. No. ... // no. ... // Okay, I already tried that. ... No luck. Okay. So let's have a look. Home, about, nothing interesting on them. What about page equals there we go. Okay, so click on one of the links first, and this is the PHP request, which page you want to go to, and then the directory that we got from the link took us to the correct password, or what is hopefully the correct password. So, oops, let's go to Natas 8 and find out. Again, copied and pasted the space at the end. So that was the problem there. Okay, so we'll close down this window. We have another input secret page. Okay, so here we have a challenge looking pretty similar to one we saw earlier, where we input a secret. So if we view the source code, try and find out what is different about it. We can see that just like the last one, it's going to check whatever we post in that secret box with the encoded secret, which in this time they've left sitting in the source code. The difference is whatever we post is going to be passed to this encode secret function first, which is also here. So it's going to take in our secret, and the secret is going to be, so whenever you see functions like this, you read from the inside out. So the secret is going to be base64 encoded, it's going to be reversed, and then it's going to be converted into hexadecimal. So that is what you see here, but we just don't know what the original value was at the moment. So there are a few ways to approach this. You could write a script, could do this through a command line Linux, but personally I would just use an online site in this instance. Now if I go to just Google PHP online interpreter, and we'll get a sandbox here that we can have a look at. Okay, so what I'm going to do is I'm going to take this code. Well, we don't need it all, but so we're going to take some of this out. We'll take this out. We don't need a function. So rather than returning, because we don't have a function to return from, we'll just set that to print. I'm going to take this encoded secret, paste it in here, add some quote marks around it, so it's a string. And again, we need to reverse what the order that this was done in. So rather than base64 encoding this, we need to convert it back from hexadecimal to binary. So we'll go hex to bin. We still want to reverse it, but we want to base64 decode it this time. Okay. For some reason you can't really see on my Firefox the buttons. I can very lightly see on my screen here that says execute code, and there we go, we have a result. Just to show you another way that this would be done, we can go to ASCII to hex, a site that I would use quite a lot. Take this hex value. Okay, so I think the theme that I'm using is not so user friendly for these sites. No problem. We'll just bring over, bring this over from my Windows system. Oops. Let's take a copy. I'll close this down. Take a copy of this hex value, just to show that. Okay. 2 seconds. Not that. Okay. So we got the hex value. If we convert it, we will get this base64 value. You can see the equal signs are on the wrong side because it's been reversed. So again, reverse text, text reverse. It's quite quick to do it just through Google. There we go, we've got a reverse value. We can go back to ASCII to hex, paste in the base64 value, and now we have this text. That's cool. I'll close that down. So you've got two different options for doing that, whichever you prefer. And again, it's not really two options, you have numerous options. But let's submit that, and we're granted the password for the next level. Cool, so let's close these down, leave page, and go over to Natas 9. Okay, cool. So this challenge it has a text box where we can find words containing whatever. We can view the source code. So source code saying if the array key exists, then key equals whatever we type in. If the key is not blank, then pass through and grep out whatever the key was from a dictionary. So if we go back here, if I just search, I'm going to get nothing. If I search this, 2 quotes, I'm going to get a list of everything from the dictionary. The issue there is that there is nothing in the dictionary which looks like the password. We can try and grab Natas 10 and there doesn't seem to be anything interesting there either. However, if we try to run a command, so this this is grepping, but if we try and chain the commands along, so if I put in a semicolon there, try ls, let's see what happens. Okay, so it lists the files in that directory, which means we know that it's going to allow us to execute as many statements as we want, separated by the semicolons. So let's cat etc natas web pass natas 10, and there we go. So we get the dictionary, we also get our password. So let's jump over to Natas 10. Okay, so it looks like we have a similar challenge. We're saying for security reasons we now filter on certain characters, which makes sense. Let's have a look at the source. So they're no longer accepting semicolons, no longer going to let us pipe or use the AND key or anything else which would give us easy access or allow us to easily chain commands. So let's go back, and you will note that some characters weren't excluded here, such as characters that can be used for commenting or the wildcard, the star. So what we can do is search for .star, any files, and we'll try to get the Natas web pass and Natas 11. After this, as you know, it would have ran the dictionary.txt command, which we don't want to run, so let's comment it out. Okay, and we have the password of this level and the password of the next level as we requested. Great, so Natas 11. Close this down. Okay, so on this challenge we have a message here that cookies are protected with XOR encryption. We can change the background color, so we'll change it from white to yellow, just to test the functionality, and as usual go and have a look at the source code. So the source code on this is a bit more complex than previous challenges we've seen. I'm trying to run through it here. We have a few functions, but let's look at the main statements of the program and then we'll drill into the functions afterwards. So initially we have default data is set to an array containing show password equals no and background color equals white. So our aim is going to be to change this to yes. If we have a look down towards the bottom, the last thing that's going to be executed in the PHP script is if data show passwords equals yes, then the password for Natas 12 will be displayed. So that's the end goal here. So the next step after assigning that default data will be to assign data to equal load data default data. So we're going to pass this value into load data, and load data is going to, so we're going to have a cookie that is declared there, and then my data is set to the default data that we've just passed in. It's going to check to make sure that both of the variables exist, and then it's going to set temp data to equal this. So what's going to happen here, the cookie data is going to be base64 encoded, it's going to be XOR encrypted, and then it's going to be JSON decoded. So we'll go into these functions in a second. Let's see what happens next. So it's going to check to make sure temp data exists and show password exists, make sure the background color exists. It's then going to do some regex just to make sure whatever we've put in as the background color is correct, and it will assign then my data show password to whatever the temp data show password is, and my data background color to whatever temp data background color is. So essentially what seems to be happening here is this value which is being passed in is being encrypted. It's then being assigned here and returned. So both in the value that's returned, both the show password here and the background color here will be in encrypted form. The next stage after load data is going to check to make sure that the array exists again, the regex is okay for the background color. We don't need to really worry about that. And then it's going to run save data. So save data is going to set cookie, and it's going to use the data that we've that has been encrypted. So set cookie data, it's going to base64 encode, XOR encrypt, JSON encode the data that we're passing in. Okay, so in terms of the actual XOR function, where you can see that here we base64 decoded the cookie data, and then XOR encrypt it. So we can't see what the key is, but we are the parameter that we're passing in, which is this, is going to be set as text, and it's going to iterate for each character and XOR the character of this plain text with the key, with whatever character of the key is up next. We can't see the key, but an XOR function is a reversible function. So if we XOR the plain text with this key, we'll get ciphertext. If we XOR that ciphertext with the key, we'll get the plain text back. The cool thing that we can do here though is if we have access to the plain text and to the ciphertext, we can XOR the two of them to get the key. And once we have the key, we can modify this value, XOR it with the key, and we're all good. So how we go about doing this? Well, in the last PHP sort of challenges we did, we took a copy of some of the code and went through to an online PHP interpreter. Again, you don't need to use an online interpreter. I'm gonna use it because I don't really write much PHP. I think this is a pretty easy way to just deal with a quick, simple challenge. We don't really need it to be in a function. Oops. We don't really need it to be in a function. Oops again. But we want it to print this rather than return it, so it's not going to be in a function. Okay, we also want just to add our PHP tags in here. So we don't have the key, but if we flick back here, we do have the plain text, and we can get a hold of the ciphertext, because the ciphertext after all is just the cookie, which is the encrypted version of this. So let's paste this in as our plain text. Okay. We will also need to, if we go back and see that this was JSON encoded, there's base64 decoding used. So for this, we will set JSON encode, and then array, add our tags in at the other side, our closing brackets, correct the spelling. Just going to JSON encode this. This is our plain text, and then we need to get our ciphertext, which is a cookie. So what we can do for this is we can go back to Burp Suite, turn on intercept, and refresh this page. Go back to Burp. You can also get this from Firefox if you go to if you're using Firebug or just the developer tool from F12 as we saw before. Oops, I'm copying. Okay, so we want to copy the data cookie, as you can see here. We don't need this at the end. So we'll take a copy of that. We'll turn off intercept and go back to set this as our key. Now we will also want to base64 decode. You can see here base64 decode is used. Base64 encode in this case, we're gonna base64 decode it. Okay. So base64 decode. Okay, I think that's all good. Let's try and run that. Okay, no, just a slight spelling mistake. Try again. Okay. And we have our key. So you can see, as is quite often the case with XOR encryption particularly, that the key is repeated. So it looks like it's a 4-character key which is being repeated depending on the length of the string that we're looking to encrypt. So let us take a copy of the key, and we know now that that is our new key. It's a bit annoying the way the tags work on this sometimes. Let's paste that in there. So that's our key, and then we have a JSON encoded array, we have our value, but instead of setting that to no, we'll set it to yes, and execute. Oh, okay, doesn't look too good. Okay, one minor mistake we were missing there was the base64 encode. So base64 encoding and XOR encrypting, or well, let's do this in reverse. We're JSON encoding the data, we're XOR encrypting it, and then we're base64 encoding it. So if we go back here, we are JSON encoding the data, we are XOR encrypting it, we then need to base64 encode it as well. So let's put in here base64 encode before we print out the text. And there we go. So we have a new cookie value. We could go ahead and change the background color. So let's take a copy of this. Let's go back, and we want to turn on intercept. Let's just refresh. Go back to Burp Suite and change the data. Oh, remember we want to keep that percentage 3D at the end. Paste in the new data, forward it along, turn off intercept, and there we go. Didn't actually change the background color for some reason, but that's fine. We have our password. That's all we came here for. So let's move over to Natas 12. Okay, so on this challenge we have a button to browse and select a file, a JPEG image, maximum of 1 KB, and then we can upload the file. So as usual, let's have a look at the source code. We have a few functions here, but let's run through the code that's actually executed when we submit the form, or submit the image, I say. Okay, so it's checking to make sure that the file name exists, that we have indeed selected a file. If it does, then it's going to set the target path to make random path from file name, where it's going to take the file name from upload. So whatever we type in, or whatever's entered into that upload box. So the make random path from file name, what's it doing? It's taking the directory and a file name, and it gets the extension, so path info. In order to do that, it uses path info, file name, path info extension, so it's going to get a .jpg, and then it's going to return make random path with that directory and extension. Okay, so the make random path is a do while loop, so while the file exists, it's going to do this. It's going to set the path to equal directory concatenated with a / concatenated with gen random string concatenated with the extension, and it's going to return that path. So gen random string is where all the magic happens. We have a length defined as 10. We have characters, which is 0 through to 9, and then A to Z in lowercase, so we have a total of 36 characters right here. Then we have a blank string, so we have a for loop which is running from 0 to lengths from 0 to 10, and on each iteration it is concatenating the string, which is going to add a character each time, with one of these characters, but using empty rand 0 through to the length of characters -1, so 36 -1, 35. So essentially on each one, each time it's going to select a random character through here until it's got 10 characters, then it's going to return the string. Then we have our target path. Next, it will ensure that the file size is less than 1000 bytes. If it's over, it's going to say file is too big. If it's within the limit, then it's going to check if move upload file, files, upload file, temp name, target path. Okay, so if the upload is successful, it's going to echo out that the path and say it's been uploaded. Otherwise, it's just going to say there's been an error uploading the file. Please try again. So let's go back and actually browse through to a file. I had to try and pick up a small image for this. It's not that easy. I'm just using a very small icon, as you can see, which just about meets the criteria. We hit upload, and there we have our random file name. So how will we go about exploiting this? You'll notice that whenever we select a file there, in the source code it was taking the file extension. Let's see where it did that. Extension, path info extension. So if we can upload something else that's not a JPEG file, it's just a script that we can execute, and we should be able to pull back the password for the next level. So let's go to the desktop here, or let's CD to the desktop. Let's create a new file, and we will call the file test.php. We need to have our opening and closing tags, and we can set this to pass through and get. So we'll get the command shell cmd. Let's write that and try and minimize this. Let's just try first of all and upload test.php. Okay, so you can see it's uploaded it, but it's got the .jpeg extension. Cannot be displayed because it has errors. So that's no good. We need that to be a PHP extension. But if we set that to the PHP file and then intercept it as we have with previous challenges, hit upload, and we want to intercept the request, we can see it's being called this random file name .jpeg. We want it to be .php. Let's forward that through, turn off intercept, and there we go. PHP has been uploaded. Okay, so we can now run that file. So what we can do now is access the CMD. We can set this to CMD equals cat, and as we have previously, we want to cat out the Natas web pass, this time Natas 13, and this time we get ourselves a password. So let's try and go over to Natas 13, and the password worked fine. Okay, so it looks like they have modified the code. Similar challenge, it's going to be a similar challenge, but for security reasons they now only accept image files. So they've obviously made this a little bit more difficult. Let's close down a few of these windows. Okay, and let's have a look at the source code. So looking quite similar here, looks like the same function. Let's go down and have a look to see what they've changed. So the script's running again, making random file path, which from file name, which looks to be pretty similar. Okay, I think these functions are the same. What they've actually changed here is they check to see if the file is too big. Then they will also check if it's image type. If it's not an image type file, then we're going to get file is not an image. So just to verify that, let's try and upload this. Let's intercept the request and hit upload. We'll try and change this to PHP once again and forward it on. Okay, file is not an image. So the same trick's not going to work twice. So the key thing for this challenge is to consider the lines that have been modified, how this actually works. So exif image type will actually just check the signature of the file. So the first couple of characters in a file will determine what kind of file it is. If we go back and have a look at Let's go into hex editor and into pictures and cat. Okay, so this is actually this was originally a PNG. That's no good. It might actually be okay. I mean, I'm not too sure whether it's specifically checking for JPEG or not. But anyway, we can see that the signature at the start of this file, first few bytes are FFDAFFEO. So let's, on our desktop, let's do the same. Hex editor. Now we're going to want to add a couple of characters potentially. Let's have a look at the test PHP. Okay, yeah. So we don't want to replace the opening tag here. So you can see that if we replace these, it's going to replace these. So let's first of all exit without saving. Let's vim into this. We should be able to add a couple of comments. Let's find out. Or yeah, let's see. Let's try and just put in a few spaces there. Hex editor. Okay, so you can see that we've put in 4 spaces before that actually starts. Now what we're going to want to do is modify these. So we want FFDAFFE0, FFDAFFE0, and then we want to exit and save. Okay, so let's try now and close this down without saving. Let's try and go back to Firefox. Let's select our modified PHP file and go back to Burp Suite, turn on Intercept and hit Upload File. Just as before, the extension has been changed to JPEG. We want it to be PHP because it's not actually really checking the extension. That EXIF image type is checking the first 4 bytes of the file. So that's fine. Let's forward it, turn off Intercept. Okay, image has been uploaded. Great, we have the same thing again. So as we did previously, let's set cmd equals cat etc natas webpass and natas 14, and there we go, we have our password for natas 14. Let's go and make sure it works okay. Natas, oops, it won't work without a password. Natas 14, paste in the password, okay. And we're on to the next level. We can see we have a username and password box. And let's close this down and take a look at the source code here. Okay, so what's happening in the source code? We have no specific functions. We have a username password input box, and it's checking to make sure the username exists. We can connect to an SQL database with Natas 14 sensitive password. That's okay, we already know what the password is for that. And MySQL select DB, selecting the database Natas 14 and passing in link, which was this command. Okay, and then it's running a query. Select all from users where the username equals the request username and the password equals request password. And that's going to execute the query. It's going to return, okay. It's going to execute the query, and then if my SQL number of rows is greater than 0, successful. If not, okay. Okay, let's just try this with the Natas 14 and the actual password for Natas 14. Access denied, okay. This might be just a basic SQL injection, so let's try Natas 14. Let's end the statement, well, not end the statement, but end that parameter and say or 1 equals 1. So whenever it's passed in Natas 14, it's going to put that inside a parameter. If we end the parameter and then add in our own, then it's going to end the parameter here, hopefully. And then password, we'll just put in test. Access denied. Okay, Natas. Let's just try or. Let's try it with quotes. Or 1 equals 1 and test. Access denied. Okay. Let's try again with the same value input into both username and password. Great. Okay, oops. So if we go back to the source code there, okay, so the SQL injection needed to be performed on both. So it's checking to make sure that the password and the username were both okay there. You can also see that it's checking first if array key exists debug, then execute query, echo the executing query. So if we actually added a debug parameter, then that would have given us a debug option. Let me just copy and paste this, go back and put in test, login. Okay. You'll need to do this by the looks of it on, okay, test, open up Burp Suite, login. Okay, Burp Suite, username, pass, and okay, password test, and debug. Turn off intercept. Okay, that still didn't. Bring up the debug screen. Okay, I'm not too sure what we're missing there. You should be able to. Let's set username equals test and password equals test and debug. Okay, so there we get a query. So depending on what version of SQL is used or the syntax that they've used for developing it will depend on what you saw us trying with single quotes there at the start. If this had if they had used single quotes here, we would have needed to end the string with a single quote in order to get through. So depending on the website you might be trying this sort of stuff on is going to have a big impact on whether or not it works. So if debug is on, which generally won't be, it shouldn't be, then you can use that to try and get some more information about how things are being processed on the back end. Okay, so let's close that down. Just realizing now that I think may have copied and pasted over the passwords. I'm just going to grab it again and go to Natas 15. Okay, so we might have a similar question here. I was checking for a username, check to see if it exists. Once again, let's take a look at the source code. So if we go over to the source code, the first thing we'll notice is that there's a create table users statement with a username and a password field, both up to 64 characters long, and if nothing is entered then it will default to null. So this has been commented out, but we already know then how the database is set up. Again, as we've seen previously, it's checking to make sure the username exists in the request. It will then make the connection to the SQL database, search for the username, and will return whether the user exists or the user doesn't exist. So if we go back here and enter in Natas 16, check existence, the user exists, that's fine. There is no point in doing just the 1 equals 1 statement again. We did see that the default for that database is null, so for the fields in the database, so it's worth also checking, and password is null, and 1 equals 1. And we get this user does not exist. So the reason for this, if we go back and change this to not null, we get this user exists. So basically it's because it's anding this statement, we're saying if the user exists and it's null, it's returning false, which just in terms of this is just this generic message, the user doesn't exist, because there are no rows returned where the password equals null and the username equals that. Whenever we set it to not null, we get this user exists because it's found one row where the user is Natas 16 and the password does exist. So it's not going to be as easy as just entering null as a password. Unfortunately, it would be nice. So what we can do is go over to Burp Suite and turn on our intercept. If we enter Natas 16 and left, password 1 equals A, hit check existence, and we can go over to Burp Suite. We can see that this is checking that the first character, whether the first character in the password is A. So we can send this through to the intruder option and modify the request. So we want to essentially cycle through the alphabet. If we set this to payloads, so all we're really wanting to change is the A value, so that's going to be the variable we're going to change. We don't want to change any of this stuff. Okay. Oh, missed one. There we go. Okay, so this is all we want to change. let's go to the payloads. For this, if we select simple list and configure simple list, so we don't want to load, let's custom iterator numbers. We can go to brute forcer. There's a character set. There'll be a few options for doing this, but let's just do this and set minimum length 1 1. So it should just loop through each of these. Okay, and let's try and start attack. Yep, it's throttled, that's fine. So what we're looking for is for something that's going to look a little bit different in the responses. It will take a little while to run through it because it is a throttled version. Unfortunately, I can't afford the Pro version. And what do we see here? We see a value which is showing differently, and that's exactly what we were looking for. So let's minimize this for now. Go back to the intruder attack. Okay, so we know then that the first character of this is going to be a W. The issue is, let's close this down. It was only really checking for a capital W there, so set this to check existence W. Let's turn off our intercept. This user doesn't exist. Okay. This user exists. Okay. So for W, that's fine. If we change this to capital W, it's also fine. So we'll need to modify. We'll need to work around this so that we get the correct upper and lowercase values. So I'm going to take quite a lazy route to solve this by using somebody else's solution. It's a Python solution you can find at this GitHub address. So if you clone this, I would recommend, if you wanted to improve your Python skills or want to do this in a different language, it's probably a good idea. I'm trying to get through a lot of these challenges pretty quickly, so I think as long as you understand what the solution is doing, I wouldn't worry about it too much. But again, you're going to be writing, if you're going to go and do sort of live CTFs, you're going to be having to write a lot of these scripts manually because there will be no write-ups. They won't be all the same, so learning some Python is a good idea. So I've downloaded this script. We can see the URL is defined, the headers are defined, and we have a table containing all digits, ASCII uppercase and ASCII lowercase. We have our username, and this is also adding in password and a variable here, which will be, so that basically it's going to be checking for the first character for each character. So that's kind of similar to what we were. That's what will be entered into the username box. Okay, and then what's going to run is we're going to run through a loop going. It's going to run 64 times. initially it sets low to 0, high to the length of this table, all digits uppercase and lowercase, and mid to half of that, so this divided by 2. It's then going to run a loop and say while mid is not equal to low, so while it's not 0, it's going to do this check password. So if check password is passing in the current index of the loop, a greater than symbol, and the character from this table, which is at the mid position, which initially will be half of all of these values, which I believe will be, I was thinking 62, but maybe it's 64, I'm not too sure. I mean, it's going to be both alphabets, and I would have thought 0 through to 9, but so yeah, it's going to pass that in, and then check password. What's happening here? So we have a postdict is set to username, and username where it's passing in the position that we've passed here, the I script, subscript, the greater than symbol, and the current character, which initially, let's just say that's A, let's say this is 1. It's going to create a post request, so it's going to URL encode this, encode it as ASCII, and this is being used to parse. It's basically creating our post data, which is then being put into a request along with this URL and these headers, and it's going to open up that URL with that request, and it's going to read from the body whether this user exists, is greater than or equal to 0. So it's looking to find out whether we're getting a true or false statement depending on whichever character has been submitted there as the first character. So we know that there's only actually 32, so this is running 64 times because the password field is up to 64 characters. We know it's only going to be 32 characters, but it's going to run that many times anyway. So we could modify the script as well just to make it a bit more efficient, but it should be fine. So it's going to run through that. It's going to then, if that is true, if this comes back true, it's going to set low to mid. So let's say the first character did equals, say it was checking A for the first character in a password, it did equals yes, it would be setting low to equal mid, which let's say there was 32, or 31 I think it would be, and then it will keep looping through that until that gets to till mid equals 0. If this returned false, then we will get high is equal to mid. So it'll run through that right to the end. It's going to set on each loop, it's going to set the new mid value, and then once this is finished running, it's going to run check password again with the table low, and if it gets back a true result, so yeah, if the user exists, then it will append that character into the password. If not, then it will be the high value, because it just depends which one of these returned true. So whichever one returns true by the time the loop has finished running, it will append it to the password, and then once this is run 64 times, it will print out our password. So let's clear this from the screen and let's try and run Python Natas level 15. Okay, we get an error here, import urllib.request, no module named request. Try to, if you get this error, try to run Python 3 Natas level 15 solution. Okay, so it looks like it's running. It may take a little while to run, so I'll pause until it's completed. Okay, so that completed. It probably took maybe a minute or just over. There's probably faster solutions out there, but as I say, you could modify that as well, because we're only looking for, well, we're only looking for 32 characters, but, well, yeah, we've got the password. That's cool. Let's try and go over to Natas 16 and paste in this password, Natas 16. Okay, and we're through. Okay, so apologies, say I didn't write my own script for that. I have a lot of challenges to get through on these over the wire stuff, and not just in this series, but in each of the series. As we go along, I'll probably take a bit more time out to write some of the scripts, but I'm pretty busy with PhD work and stuff at the moment. I would like to jump back over to my malware analysis stuff, which is a bit more relevant. So I feel a little guilty for taking that script from GitHub, but not guilty enough to go back and write my own. Anyway, so Natas 16, we now have, for security reasons, we now filter on even more certain characters, find words containing, and we have our source code here. So just to mention, that last challenge that we did, it was a blind SQL injection challenge, just in case you're looking to find any more similar challenges or read up some more information. That's what you're looking to be that's what you will be looking to search for. Okay, let's close down some of this stuff and we'll have a look at the source code.